little update on my cluster. I finally made it work. I can ping now, and it takes a while, but there it shows the first 16 MCUs which are here. I can still toggle the LEDs, and let's say set also toggle ID 0 only, and then I can change the index. It should start at, let's say, 32, and then it will reprogram over the bus the individual IDs on this board. On this board it's not possible anymore because I can't address individual MCUs anymore. So, and now when I ping it, wait for it, bam, yeah, it starts at 32. And I can now also, let's see, blink LED 33, and here we go. That works. And how I solved it, I had to rework everything, refactor the whole bus system, since I was using, let me show that here. I was using 8 bits of the bus as the ID. I changed it now, so these are basically lines that communicate somehow. And yeah, these are the lines. This is the command that triggers the start of a packet. And then we have, I changed data to be on C0 to C7, which is 8-bit. And then I added a new clock on D0, and I skipped D1 and D7 since these are the debugging pins and reset pins. So I could use them, but I skipped them. And then we have packet type, which is receive a packet from the host, transmit data from your buffer, and broadcast is basically receive a packet that's not meant only for you, but for everyone. So probably you don't want to respond or anything. And then we have an ACK, which is from the client, that is going up and down whenever clock change and the data or the clock change is acknowledged there. So we can asynchronously use the maximum speed, basically. Then we have a signal full, which is somewhat obsolete. That's there, the client can signalize, yeah, my buffer is full, stop now. And end of transmission is important. It can be set by the client and by the host. And the host indicates here packets end and ends, and you can reset everything and wait for the next comment. And the client, when the client is transmitting data, like it has a buffer of 32 bytes, it can also indicate this is the last byte of the buffer. Or if it's the header with comment, it can say end of transmission, there is nothing in the buffer. And yeah, it was a big refactor. I say a lot of stuff is needed. I introduced ring buffers and basically made some classes for the bus that needs to be implemented on the hardware layer, which is quite cool because now I can use the same base class for all the MCUs, and then we have an implementation. Wait, oops, oh no, click the wrong button. Here we go. We have the implementation which basically initializes the GPIOs correctly, interrupts, and oh yeah, I don't know if I mentioned that before. I figured out a way of the clients to respond in time, and that is using basically GPIO interrupts, which are set up here with here this is a falling edge, and the clock is on rising and falling edge for the acknowledge to be responding faster, and then we have a ton of flags which are overloaded here. So in the end, it's working now. It took me a few days, but I'm looking forward to make actually the ray tracer work on the little MCUs now, since we have a working communication. Nice.